All right, so hopefully everyone's here for intro to Python.
Yes.
Awesome. Thankfully, they also switched the rooms because I'm always worried that they'll make me teach the big one, and there's not that many people there. All right, so hi, my name is Chang. I'm a postdoctoral researcher here at the University of Washington. I'm with Ariel Rokum. I did my PhD here as well, so I'm pretty familiar with the campus. If you have any questions about if you want to do the walking tour or something like that, just let me know. Otherwise, let's get started. So hopefully everyone has been able to access our cloud on their Jupyter Hub. And I'll give you a moment to sort of nod at me if that's the case. Good. Also, people on Zoom, I have audio turned up so you can just speak whenever. I probably will not be able to see raise your hand, something like that, unless someone monitored that. And thank you. If you have a question, just shout it out. I'm not, hopefully we'll make this a little bit more informal. Otherwise, I just want to do a quick poll. How many people here have coded before, even if it wasn't in Python? Few hands, that's good. So I'll probably start with the basics. How many people have interacted with a Jupyter Hub of some sort like this?
Yes, that counts. I just
Yesterday? Okay, we're already on the same track. Very nice. All right, cool. In that case, we'll begin even further back. So hopefully everyone's been able to log into their Jupyter Hub instance, and for the most part, if you want to use your coding and your files here, that's totally fine. That's what it's here for your hackathon in the week 2, as well as do some of these tutorials. So you don't have to install anything on your personal computer, although if you do want to do that, let us know. But we'll do that offline. Basically, when you log in, you'll be able to see your file. Basically your file directory system over here on the left-hand side. And if you haven't opened anything on the right-hand side, we'll have a few options for you to select. So basically treat this as a pretty minimal computer. You can open new files here from any one of these options. So that first one I clicked here was a Python notebook. As you can also see, it opens up in your file browser as well. And you can rename it as you see fit. You have other options too. That's quite nice with this Jupyter Notebook Hub is that you have a terminal. So like here's the bash terminal for you to navigate your file system with. Your typical bash commands as well. It might be a little bit bigger to do that. But basically, right, treat it like a computer, treat it like a pretty minimal. Anything that you want to install in terms of like installing Python packages, you can do as well. We also have just your good old regular text files, and if they don't want to take notes to myself, or if you were feeling a little fancier, having a markdown file. Or for notes, or whatever else. Otherwise, in our Jupyter Hub, we have our curriculum folder. You can sort of navigate to this, and then you'll see all of the different lectures that are sort of happening now, or will be happening in this current week. You'll see that there's a Chang for my last name and intro Python, and we have a bunch of these notebooks that I placed in here prior to the start. And so we'll be going through some of this stuff as we begin. So if you want to follow along, feel free. I'm sort of a free spirit when it comes to coding type tutorials. So I oftentimes actually start from an empty notebook so that we can type along. So one, you can see my process, but also you can see where I sort of copy and paste or where I just start typing. Hopefully that it's enough to follow. So yeah. So we'll be starting with the basics tutorial, and we'll start everything in terms of like following along with content. These are for you to have in the hold, and so you can open them whenever you want. So if I speak too quickly or if I go through something too fast, they're still here for you as references. Otherwise, hopefully with me actually being up here and actually speaking, there's some utility to having me explain some stuff. But essentially, let's start off with the basics in coding, specifically coding with Python. I'll open up the floor. So people who have coded before, what other languages have you encountered or used before? MATLAB, excellent. We are all coming from that family. Anything else? R? C? Yeah, R? Yeah, okay. It's getting more popular every year, so I'm always encouraged to hear it. I also come from the land of C because life is hard and difficult. But essentially, if you guys know some MATLAB, some R, we're in pretty good shape. Most coding languages, once you learn one to some level, it's pretty transferable from one to the other. So I'll mostly be explaining some of the more Pythonic specifics here. So if you open up a notebook, here you have a cell. Basically, you can type your code here. So my variable or et cetera, et cetera. If you're from the land of R, We don't use arrows, we use equal signs. We can have variables have assignment like this, basically my variable equals 1, assigning it to be some sort of numeric variable. Now, to use a notebook, I will be using shortcuts quite often, I just can't help it. But if I have my cursor over the cell and it's Control Enter, both on a Mac and Windows, that will run the cell. So that's what actually makes the code run. There are also buttons over here. You can sort of see the play button for run in this notebook as well. You can sort of see that's where I also got my shortcut on this cell and advance enter sign. So, but basically now if I wanted to query my variable and have it print out for me, that is in existence and it is in my working environment. As you can sort of tell, if you're from the land of MATLAB, Python doesn't print anything by default. No semicolons here. If you want to have it print, you have to actually explicitly ask for prints as the function to print the variable and its contents, or in a notebook sense, you have to have it be the last item on your cell. Comments are the same usual as in most languages. It's your hash. Shortcut is Command / be careful of that. It will comment it on issues. Sure. Okay. So usual variable things. I'm also hitting SB, that's insert cell below, but you also have these buttons over here. Insert cell above, insert cell below, right? 4 additional coding blocks for you if you see there. They are over here. Yes.
Why do we choose to start a new block and not just keep writing the same way?
Why not? It's sort of a personal preference.
Oh, they're not really.
There's no, like, the one thing though is the block will run in its entirety. So if you want to do something like this and have another variable down here, you can go back and forth, but your logical flow of sequence for code might be broken. So if you have like a chunk of code that does, I don't know, calculates your standard score, you may want that to be one chunk. And then like you do something else in the next chunk.
But the next cell knows what it was before in the previous cells.
Not necessarily. So let's do my string. So for character string. Notice how there's also numbers over here. I can go back over here and rerun. Now this is the cell that ran 4, but it's above the one I just ran. So the logical flow depends on, like, you can run the whole notebook from top to bottom. That's what it does naturally. But the way that cells work is I sometimes work. I work on one and I go, okay, I feel good. I move on to the next and I'm like, oh wait, hold on, go back. Right? There's a bit more backtracking that's available to you if you want to do it cell by block by block. Yes. Yeah. That's sort of the notebook thing, but like so some encoded, so you have like Visual Studio Code, there's some settings that you can set on. Notebook, I don't think it does it for you in this setting. Going back and forth, incrementing like things. Again, notice you can do prints, be more explicit, or you can have it be a lot. Make yourself off. Your usual typical variable types, some sort of numeric, some sort of string. Hopefully that's makes sense. Your booleans, right? Your trues and falses. Once again, every coding language is a little bit different. It's a normal capital case, not all caps, not all lower, regular capital case, B capital. All right. Great. So what is sort of different about Python is that in Python, everything is an object. And so how much do people know about object-oriented programming? And probably heard the words, probably heard it somewhere. Basically, what object-oriented programming means is that every single variable, simplify this, can do more things than you imagine. So let's go with the string in our case. So if we're coming from the land of math, if I wanted to turn this into uppercase or something like that, I believe, or from R2, we would wrap this string variable in a method or a function called upper or to upper. I can't remember the exact function. but then it'll turn this string into uppercase. I think this is an error because there's no such function as upper defined in Python. That's because we have a method associated with strings that can turn it into an uppercase kind of situation. So variable dot syntax, this is sort of an object-oriented programming thing. Basically, my string has a function, has a method that can turn it into an uppercase or lowercase. Lowercase, I think capitalize. It applies. I can spell. Right? We'll do capitalization, right? There's a bunch of these methods that are sort of associated with a particular kind of object type. In our case, this object type is a string character. It can do these things. So if I try to do my variable, which is a numeric, if I try to do lower, it'll give me an error, right? What does it mean to make something lower if it's an integer? That doesn't actually work, right? So that naturally doesn't have that method associated. So we're now thinking about specific object class types as opposed to, oh, it's just a variable. It has specific properties depending on the variables it has. And this will become really apparent as we get into more complicated libraries. They all have different data types. So these are the ones that are built into Python. And you can inspect data types by having a function type, and then whatever your variable is. Can't spell. Watch me spell. So my variable was 1, it's an integer, my string character class, my boolean, right? It's a bool. Like each of these different data types have their own properties and methods associated. And again, we'll go into NumPy. NumPy arrays is another data type that NumPy, the package, has made and defined. It'll have its own properties that are not shared amongst other Pythonic objects. Inserting more cells below. Any questions so far? Yes.
Do you have semicolon concept?
Semicolon?
Yeah.
Like to not print things, like in
Yeah.
MATLAB? Yeah. By default, Python just does not print. You have to explicitly ask for it. For better or for worse. Some other data types that you just may not have encountered that's very specific to Python. We also have a none type. Notice how it also highlights itself. This is equivalent to null types. If you have seen it in other coding languages, basically having the programmer or the program explicitly return you nothing. And like that's the intended. Just wanted to make sure I mentioned it because you'll see it sometimes. So sometimes some functions or methods and other packages won't return you anything, like it won't give you an output because it's saved the file, but a return of none type to indicate to you that it's done it successfully. Our usual, so in Python, Python is what is known as something that's a lot of syntactic sugar. It's actually a really fun terminology that came across when I was an undergrad. Basically, the reason why one of the reasons why Python is so popular is because it enforces really good syntax. And one of the ways you can see that is just in a for loop. So right, our iterative loops for an iterative, I'm gonna do I because I can't spell iterative correctly every time. For I in range, I'm gonna do 5. Also can't spell. Colon. And then I'll just do print I to show you. Notice how when you're typing in your spell, it'll automatically tab for you. So in other coding languages, especially some of the more C-based ones, it's per C. But basically they don't enforce tabs or spaces because they sort of, spaces are meaningless, right? In other coding, MATLAB especially, especially. But in Python, they're meaningful. They'll actually cause error if you don't have the correct tabs. So if I run this, you'll also see it prints 0, 0, 1, 2, 3, 4. So range gives you 0, 1, 2, 4 as a function, as an iterate. So if I actually unindent, that was me doing command square brace to the left, it'll actually be an error. Indentation error, expecting an indent after the for statement on line 1. And so this is what I meant by like sort of syntactic. It's forcing you to have some sort of structure to your code. And so unindented or exiting out of the indent. Print here. Notice the indent levels. This will actually exit you out of it. Like that's how it's implied to be. There's no like ending curly breaks. There's no syntax of end or something like that. You just have to exit out. You'll have errors related with indent, which other code or spacing or other things that other coding languages don't throw errors for. And this is part of the reason why Python is very easy to learn. It's supposed to be very readable, and because of its enforced syntax. So for loop, as you can tell, pretty straightforward, hopefully. It's very similar to every other for loops in the world. And you probably have seen basically, we're going to iterate through numbers of some sort, especially for our for loops. One thing to really point out, if you're coming from a different coding language, Python is a zero-based indexer, so 0 is your first instance. Just be careful, this is probably where the most common code problem is that you have a zero-based index. Most functions also will implicitly start at 0, so usually I also break it to just in case. All right, we can loop through a lot of things. How about a list? My list, square braces, 1, 2. Random words. Lists in Python don't have to conform to any sort of specific data type. They can be anything you want. So my list here contains both numerics, float, right? Strings, booleans, whatever you want. It's all good. Run that, no errors. I'm going to comment this particular stuff out. One nice thing about Python is that you can loop through lists without having to loop through them as indices, although you can do both. So for item in my list, print item. In some languages, I know this would crash out, so this is quite nice. So implicitly, for every single item in a list, you'll loop a for loop will step through its iterable without having to index based on it. But like I said, you can do both, so let's show both. So I have 1, 2, 3, 4 random true. I have 6 things. 6. Just want to double check and make the 6s right. It starts from 0, goes to 5 or 6 things. My list, square braces, your iterative, like your actual numeric iterative. Both are usable, both have their applications. This is just one way to both index into a list or to move through list items. I see Chang some of them. How we doing? Cool. One very in the same vein, because you're probably imagining it's like I don't want to physically count off how many things are on my list every single time. Yes, of course, there's other things for your function length, for like short for length. I don't want to count it. That would just be sort of being very explicit about specifying the count.
Sorry, I didn't understand how the range 6 got us. Same thing.
Because in the range 6 version of this, my list is being iteratively subsetted. So I'm pulling out the first instance or the 0-based index, and then the first base index, second base index. I would basically, in that loop, this is what's happening every single time.
That's 6.
The 6 means it is from 0 to 6, exclusive of 6, so 0 to 5.
But then why did do the okay.
You got it? Yes. Okay, now, these are great questions. Please just shout them out and ask me. So right, you can either iterate through the items as the items themselves without having to specify any position-based index, or of course you can position-based index as in other code. Both have their utilities, personal preferences as well. Cool. Just scroll down to another cell. We also have dictionaries. There. Curly braces, they're making an appearance now. We have a key, and then we have a value. I'm gonna also use some numbers. Key number 2, more numbers. Key number 3 doesn't have to be, again, different data types, you're all good. If you're familiar with MATLAB, these are your structures. If you're from R, I guess it's sort of like a data frame, but not really. But essentially, you need to have a unique key to a whatever value. Like it can also be like another dictionary, literally. another dictionary. Dictionaries can contain whatever, you can nest them as deep as you want, although probably ideally not two, just for your sanity in mind. But you could put a collection of things. These keys are also as flexible as you want them to be. They could also be numbers too. So this is another valid key. You can also have, but basically this will be just. Say again? Yeah, so you have to refer to them either by their key to get the value associated with them. Yeah. I'm just sort of trying to make sure you know that the key itself can be anything. It could be a string. Strings are the most common because we are humans and we read English or any other language, or they could be numbers, which can be slightly confusing. There can also be other data types that I'll show. So if you wanted to, I would have print my dictionary so you can see what it looks like in the console. Scroll down. You can sort of see that the syntax of it looks exactly as the way I typed it.
When I ran mine, it showed me an error. It said that P3 through invalid syntax. But
You might have be missing a comma at the end.
I got like super lazy considering how easy.
Yeah. Commas sometimes come natural. Commas between your keys and values. And if you wanted to refer to one specific thing, square braces. And the square braces, put your key in there. It'll give you the value of that. The reason why I mentioned that it could be slightly confusing is that if you remember, our list can be referred to, you scroll up. Our list can also be referred to square braces numbers like this. Because I have a key that is 5, technically I can do that too. So just be careful. Just keep track of yourself. Also, a good moment to point out, notice how even though I have two things I wanted to print, I just added another line. The only thing that prints was the last line in that cell block. If I wanted both, I do need to be explicit about my statements. Okay, so these probably have some homologs and other coding languages that you may have already encountered before. One thing that is a bit more Pythonic is known as a tuple. Now, this doesn't look very much different from a list. I would assume something very similar. Specify a list be. But if I query what kind of data types these are, they will actually be different. So type my tuple, will definitely be a tuple. Type my list. Right, class tuple, class list. Note the syntax is so slightly different. One is parentheses, one is square braces. Be careful.
So how do we like? What is really different between the parentheses?
Very good question. That's where we're going next. So why do these things have differences? Well, tuples can only be one data type. Lists can be, I could put strings in there, I could put floats and integers, whatever you want. Tuples have to be the same data type. So ins here, or the other thing about tuples is that they're immutable. This is what I wanted to mention, is that immutable means that you can't change it once it's been defined. So let's start off with my list. I can query the first item in my list, right? That one. If I actually wanted to append, there's a method called append for lists to add things to the end. Let's add a 6 to the end of my list because that makes sense. Right, I appended the number 6 to the end of my list, printed my list 1, 2, 3, 4, 5, 6. Let's try that with a tuple. Right, remember what I said about data types? Some data types don't have certain kinds of methods associated with them. I try append, errors out. I can't append anything. Okay, sure, I can't append anything. Let me see if I want to change maybe the first number. Change that to 6. I also can't do that. Type error. Tuple often does not support item assignment. Once a tuple has been assigned, unlike a list, my list, I can append it. You saw that before. If I want to change that first number to 6, I should also comment out my error. This I can do that just fine. Correct. Mostly, I don't use tuples actually a lot in my day-to-day life. It's mostly when you interact with other packages, people will use tuples. So like the shape of, let's say, a data frame, they don't want you to touch it. It is that shape. They might return to you a tuple. And you can refer to the rows and numbers just fine. You can actually, so if I wanted to see what my tuple values are, that's no problem. Like me seeing and me viewing that number, like that second number in the tuple, fully good. If you want to change it, you can. Again, it's mostly because this is like, oh, why would I ever use this in my coding? It's not because you're going to do it in Python because it's open source and the way that our community encourages it. You'll interact with this because other people. You can, of course, though, it's not like it's set in stone forever. Change the data type. So if I'm going to move down here, so copy and paste my tuple list converted into a list. Then you can start doing things to it as well. Right. Convert the data type. That solves your problem. If you want to dependent, you can actually turn it back into a tuple after that as well with a tuple. It's just like in that moment, that object has that characteristic and those properties. You have to play in that role. All people are typing. Cool. I mentioned these methods a lot, but how do you know what each data type has, especially as we get more complicated packages? Like these ones are the base Python, so those are pretty well known overall. But what I mentioned, as you get more complicated classes, you maybe want to take a look. So it's very well documented package like NumPy. You can look it up. But if you're feeling particularly lazy, there is this function called dir, and you can type in your variable and of that data class, and you'll get all of these different methods associated with it. There's our append right there. We also have a clear to count stuff in our list, extend our list, right? There's a bunch of additional properties associated. Notice how there's a bunch of underscore extra stuff. This is, I'm not going to cover this, a little bit advanced, but basically, these are built-ins or hidden methods. Essentially, this controls the behavior even more fundamentally. We'll talk a little bit more about them. Just for now, if you see the ones without the underscores, these are the public. I don't know, people have encountered that kind of concept before, but public methods that are ready for users to interface with, whereas hidden ones are sort of implied to not touch. Like these are how this whole entire data type works. Don't have them. You may, again, private functions, private methods, they're just sort of there for scaffolding usually. Last kind of control structure that I just wanted to mention was you have your for loops, the while loop looks the same, while true, blah, 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 blah. That while loop is also very similar. We'll keep on running until this particular condition throws false. We don't really use those too much, but the more important one is if, let's say my variable is less than 1, print hello. This is more the part I wanted to show you. Ellen. This is just the control structure for your if, elif, not else, if, elif, and then else. Else, and just like with any kind of if, elif, else, you don't need to use every single one. You can just have if, you just have if, elif, you don't need the else, or you can have a whole thing. Conditions are very similar across Python. Also, oh, sorry, I should also mention, please know the indents, right? The indents are specific towards, this is for the if, this is for the elif, this is for the else. So,
Interestingly, I don't what I did, but my indentations are not doing the same thing that yours is doing. Like for example, I did if, and then I click, it went the prints exactly under if. So I don't know what did I do.
I think that's that. I think sometimes, so if you notice on my first right there, I entered under my loop. even though I'm typing it.
Oh, so you're doing it.
You can do it manually, just in a minute. Sometimes it sort of messes up with going back and forth. The conditionals are pretty simple map, greater than, less than, it's greater than, two. So. And these are also good things. We can also do equality, so something like this. Double equal signs for equality. Something nice about Python is so you can also type out not. I don't know what other coding languages they have squiggles, they have exclamation point. Not is your universal, so not true should be false if I can type this correctly. So not, and then your condition, combining conditions, so condition one, and type out the word and. There's no simple language, it's just and. Two. Is that, of course, sure. So, have you encountered a while loop before? Okay, very good. So while loops are very similar to for loops in that they will iterate through basically one at a time the code that's in the while loop. They will continue to do that until this condition turns into false. So let me be very explicit. Let me make a counter variable starting at 0. I have not counted yet. While counter is less than 10, I'm going to actually print counter and then add 1 to the counter. Plus 1. Please note some fun Python things. Counter plus equal 1 is also the same. I run this. You'll see that the count this while loop only goes up until 9. Because that's up until the point that that condition is true. Does that make sense? Of course. Any other questions? Doing okay? All right. Last but not least is we have functions. So def is how you indicate the start of a function. Find function. And then your parentheses for your arguments if you have any. For this one, let's just print hello. And then we run. And nothing happens because I only defined my function. If I wanted to actually print hello, I have to call my function. So function. If I wanted to add my arguments as I would for any other functions, let's go x and y, because why not? Let's maybe print x, print y. If I try to call this without any arguments, you'll see that this is an error. You're missing required positional arguments, x and y. Okay, let's print 1 and 2. Nice. Very simple function to help you print stuff for no good reason. Just explaining. But what you can do with these is that if you don't have anything defined for the arguments, these are considered required. If you have arguments that have assignments inside the function definition, these are considered optional and can be specified if you were to add an additional. So let me first just run this with the hello y defined to be hello. We're looking good. And then we have comma y equals so. And then that's how we change it. When it's something is optional, we typically like to define it with the argument name itself. The way you define optional arguments is after the required ones and with names as well. Good. They're okay.
Why doesn't print? I wrote the same thing.
Did you not write this line right here for the next term my function?
It did.
Okay.
Oh, here you go. It's the indentation.
Yes. All right. Wonderful. That's usually most of the basics. Again, there's more stuff in the actual notebook itself. Feel free to peruse it. Feel free to Google it. Feel free to ask AI, although questionable sometimes. In order to gain a bit more Python knowledge about that, there's a lot of things you can do here that I didn't cover. Like you can count letters in a string. There's a bunch of those extra methods that are just sort of built in. But I wanted to jump into the NumPy one, mostly because you'll start to interact with NumPy and then pandas a lot more as you go into your hackathon level kind of work. Essentially, NumPy is that. I don't know how to describe it. Basically, they were like, Python is not that. Let's make it more. Here's Pandas is also of the land of R. R is really good with CSVs and tables and data frames. They're like, Python is also not data frames. Let's make it data frames. So these are your two. And as we do scientific computing, in coding, we deal with numbers and we do. So it's two very big things. A lot of even more complicated packages are typically built off of these two packages. So it's pretty good to know them at the base level. Go off Rails a little bit, just for look up your NumPy. So NumPy is pretty stable, although don't quote me. They recently made a release that broke everything. So whatever it is now, it's primarily stable. But for any Python package that should be well documented, you should be able to Google it, and you should be able to go like to their web page and just click through. They should have documentation for something that's so highly and widely used. If I don't know it, it's probably there. If you feel like you don't want to read the millions of pages that they have, maybe AI can help you summarize it, but it's also pretty good to just go scroll through here. You notice that I'm just sort of clicking through the website. They're talking about how to arrays, how do I work different kinds of string functionality. Like they have a bunch of things in here. Linear algebra, logic functions, like your math functions, basically. It's all in. If you can't find it, you can Google it. I might not know everything about NumPy. It's pretty big, so I don't think I actually do everything about it. Same with Pandas. Pandas should be Python data analysis library. Click on it. Getting started. Documentation. API references when I click on a lot. See data frames, indexing objects, group files. These are all things that you should become familiar with these packages. If it's a package that's off on GitHub and no one's written documentation for, of course not. There will not be nice resources like this for you, but the big ones definitely should. So you should get familiar with navigating them, especially as we get more familiar with Python. Again, if I don't know it, we'll probably. So for NumPy, in order to import packages that we have that are not part of the base Python set, the syntax is import, and then the package name, however they use the role specified. In our case, NumPy is just NumPy. We can also give it a shorthand name that most people do. Import NumPy as. If you run that, it doesn't error out. But what this does is it gives you access to a whole suite of regular math functions. Yeah, in MATLAB we have mean just natively. Python doesn't have that. Python was made for math. But NumPy does. Now we have our mean function. I put my list in. Like this stuff I hope is pretty familiar and intuitive for people who have come from some other code. But if I wanted to calculate the mean, standard deviation, square root, exponential, like your typical math stuff, it's in NumPy. Now, here's the thing that I want to be pretty careful about when I speak about it, is that, okay, we covered this, keep on typing this. Please feel free to copy and paste it from above. I type pretty things. Type my, it's a list. I hope that is apparent. Now, if I do something like this, my list MP array, not too much difference. What I'm doing is wrapping around numbers 1, 2, 3, 4 in this function called mp.array. So I'm going into the Python library, accessing their function called array, putting my list of numbers inside of it, and I will now call it. And you'll notice that the printing is changing. Has the word array in front, and then still the same number. Okay, cool, printing's changed, but I still got my 4 numbers. Is that any interesting? Okay, let's check the type. Oh, look at that. It's not a list type. It's a NumPy ND array, n-dimensional array. Just like I mentioned before, Python is an object-oriented object-oriented coding language. my list, the NumPy array, now has a bunch of methods it didn't have before. Now it has .mean, which previously before, I'm going back up the cell. .mean, no such thing. List object has no attribute. Oh, but this does, and that's because it's a NumPy array. Similarly, right? Similarly to how my integer doesn't have an upper, but my string class did. My NumPy array now has my regular math stuff too. We also have standard deviation. I also have, I can square it, I can power it, I can do whatever, right? You can sort of see the utility of having to define my class, right? Because in Python too, remember, lists can be any object. It could be numbers, it could be strings, it could be whatever. NumPy arrays have no numbers. So there's some enforcing of context for how these things become different objects. Another fun thing about NumPy arrays, although I should now stop calling it this. Is that here's another pretty fun thing about Python. That's why NumPy was made. If I wanted to add two lists together, what actually happens is that they append onto each other. These are Python lists I'm trying to add, and if you try to do math, this is not the math you want to do. This is what my affectionate little godson calls monkey math. But essentially, you wanted to actually add each element by themselves, right? Other coding languages do that naturally. That is not the default in Python. The default in Python is actually a lot more manipulation of the data. NumPy can wrap it around arrays. Okay. Then there's your classic element-wise addition. So be careful. Data types really matter in Python, especially if you want to do math that we probably take them to do. Our scientific kids watching. So that's our one vector kind of array. As you can imagine, my matrix, oh gosh. Slow, so don't do this up. List of lists. Basically, right. It looks like a matrix if you want to format it this way. What in essence it is a list of lists. So there's a bigger outer wrapper list here that you can see by square braces, and then each individual item inside it is a list itself. So my matrix started printed. It also prints nicely too. Other common attributes that you might be seeing in other people's code: shape tells you the number of rows, number of columns. Notice it returns a 2 form. I wonder why. Because that hopefully the object of this thing doesn't change. Also do mean again. Mean across the whole entire matrix. You can also specify arguments across different axes. Again, people who come from Python, come from MATLAB, this seems familiar with your specification of different dimensions. R2, I believe it's also beginning as well. But basically the type of math that you traditionally do on matrices or ND matrices, so they are for you as well. Sorry.
What does the axis number mean?
Axis number refers to across which way do I want to take the mean. So in this case, axis 0 means column wise. So notice that this is the average and there's 4 numbers out. This is the average of the first column, second column, third column, fourth column separately. If I change it to axis 1, that means I'm going row wise as opposed to column wise. If I had a third dimension, keep on going.
Yes, first, it seems that now it cannot print anything like
That answer to my number. Yep, thank you. So, any other questions about the list? Okay. So, yes. Yes. Yes, very similar. Yeah, you can do like row concat, column concat, third dimension concat. I think it's good comment. I think it's np dot concat. Cat with an E? I can never remember this. Dang it. NumPy. Row concatenate. Oh, concatenate, gosh darn it.
It doesn't get like, hey, you called me this, like.
There is a tab complete, so let's say I stop here and it's a tab, it does pop up. VS Code is a bit nicer about it, but sometimes I get feelings like that's like literally just like, I can't remember. And then you can specify your range.
So
Yes.
when we kind of introduced our array in the NP, so we can stop calling NP dots, right? Is that kind of correct?
Yeah, so NP dot is referring to the fact that you want to use whatever function is the NumPy package. So
But if I take it first, like, you know, how we were saying, like, NP dot array is one, this is my number, like my list is that, then my list is already in NP, so I don't need to do the.
yeah, you don't need to do it again. Once it's in that data type, the way that NumPy works is that it can stay in that data type. Same, but you can always do conversion. Grab the function list, wrap it around. Indexing into matrices, so my matrix. Similar row, comma, column, comma, third dimension, fourth dimension. Similar, just remember zero-based indexing, so if I want the first row, comma, everything, colon. Very similar to MATLAB and also for people who want. If you want to just get the first and second number from the first, first and second row, oh gosh, my brain stops moving. You don't need to specify the start, you can also just sort of go up to, or you can go starting for end from. Those are all okay. If you're still getting familiar with the zero-based indexing, just be explicit for now. I just want to show you that it's possible, we'll see that. Same thing with columns, so all rows, column 3. That's column 1. Turns it back. Basically subsetting whatever part of this matrix that you want. If this had more dimensions, then you start adding more dimensions. So functionality, I don't tend to go through NumPy too much. You know your math functions. These are the ones that this is where you get them from. Sometimes they're linear algebra stuff, so like maybe some matrix multiplication that's not available in NumPy. There is another package called SciPy. This also has a few linear algebra functions for you. If I remember correctly, like matrix multiply, math mult is a matrix multiplication. I also wanted to mention that you'll notice for me, I downloaded this before, but there's .npy file that's in my folder. I don't believe you guys have it. That's because NPS lib is another package. If you try to type it in yours, I don't believe it's installed. I'll want to install it. You click Canon, terminal, hit install NPS lib. Will install packages. So if you wanted NumPy, that's how you also install NumPy. Hit install NumPy, although we already have it. This is how we get extra packages for our current workspace. I already did this beforehand, so again, don't worry too much. Let me also, from this library, import a specific function. So you can also do that. If I also only wanted import from NumPy, import mean, that also works. I'm just pulling the mean function. Now, instead of having to call it NumPy mean, I can actually just call it mean. That's just sort of what is implied there. People don't tend to import specific functions from these big packages because having the specification NP mean is meaningful, right? I want to use the mean function from NumPy. Or if you think of more complicated, I want to do a specific algorithm from this package. Sometimes names will overlap, so that's why we don't tend to just import functions specifically in every single case. So I'll move this aside. basically, you can also save out your data. So NumPy also can do save. Save. And then you can specify my matrix, fingers crossed. Remember this correctly. These other way around. How do I run that? Hopefully this is also a moment. I don't remember this off the bat. File first, then the NumPy. Of course. If I wanted to save my matrix, like my tiny matrix of numbers, you can also refresh that right there. There it is. You can now then pull them down. Loaded matrix equals MP load by matrix size. Just to prove to you, it's just the same matrix, but saved out, saved in. So that's one way to write out for you guys. I want to save out a giant matrix of numbers. That's one option. Yes, that's fine.
Would you please show us how to do things spelling again?
Of course. So notice there's another tab here. I have my terminal still left open. Hopefully you have something similar. There's a black flashing cursor here. Pip. Python install package. I believe it's what it's short for. Install. Package name. So the one that we were doing was NBS lib. NBS.
Yeah, I was just. Okay. You can put in terminal. Yes. Okay. Terminal.
Sorry, a little bit better. I believe this is short for natural data set something seen. It's just some package with some data in it. That's why I'm using it. Not very specific. But we can always, of course, look it up. Data science methodology comes from a book. So sometimes people publish books with packages. This is one of them. The reason why I wanted to mention it is because there is a load data function. I think it's like basically bold. And not off top. Something to buy resources here. This particular function lets this stuff. If you were to run this and you didn't have this file and you did download the library, you would start downloading this file. This bold.npy file. Giving myself some more cells at the bottom. So this bold, now you're starting to see ... It's a really large matrix. And it's bold data actually. So if I do .shape, oh, it's got 4 dimensions there. X, Y, Z, time for bold. So you can sort of see the power of maybe averaging across the entire of the 1, 2, 3, 4. Last dimension. You can also chain up these methods. I'm going quick just to sort of show you what's possible, not so much that you type it. But if I do the average across the 3rd dimension, it gets reduced down, that 180 is gone. Shape is turned into an actual 3D image here. It's now an average of the bold image across the entire time series. If I wanted to refer to the 20th of the B slice, here's another way to do short. So we can do all rows, all columns, and 20. That's what I showed you guys before. Nice thing about Python and that we have short annotations. We can actually do every single dimension up until the one I want. This is also the ones. I'll write this same exact thing right above. You can see sort of the similarities. Same thing. It's just a nice shorter syntax because sometimes your n-dimensional arrays are n-dimensional. You don't know how long they are. Fun fact about storing data, that usually means your first or your last dimension is usually the one that you want to fix it. Just keep it simple for yourself. Okay. Any questions? I went through that pretty quick. I'm happy to talk about it now. It's just I wanted to show you what's possible. Okay. 2 pandas. How much time do I have? Okay, doing good. Pandas. So anybody here who has encountered R, anyone who's encountered a CSV file or some file, this is what it does for you. If anyone's very fluent in the tidyverse, this is Python's solution to that. This is their. So if you know anything about tidyverse or data frames, if you can do it in tidyverse, you can do it. Do I have personal preference? Actually, so I love R, I also love Python. Pick your favorite. I'm teaching Python today. So just like before, you want to import packages, import pandas. The typical convention is PD. So if you see PD dot whatever, that's where we're from. If NumPy is to lists and lists of lists for numeric stuff, pandas is really for dictionaries. Because you can sort of imagine pretty quickly a field is a column header, and the data associated with is the rest of the data frame itself. I'm actually not going to type because this is a little problematic. Copy and paste instead. Feel free to copy and paste. I'll also leave this up. But essentially, you can sort of see how inside the pandas.dataframe call, turning this dictionary right here, curly braces, right? Field A, key B, key C, associated list of strings. That's a dictionary on the inner. We're turning that data frame. We're turning that dictionary into a pandas data frame object. So previously, the dictionary would print that way, but my idea will print nice. That's also the nice thing about having object programming. You can also specify the way it prints out. So this is actually nice. And you can see that, just like I said, the keys turn into the column headers. And you see those really solid zeros, 1, 2, 3. That's just the row. Sorry, I'm messing with this. If you want to remove. Yeah. So if you wanted to just index, sorry, the first row as well. So my bad. So it's basically ilim is the function, sorry, the method to index into these data frames. And if you wanted to remove it, you can just delete it. Okay. Going back to this. So as you can imagine, pandas also has a type. Although printing it usually will give it a type. Pandas.for.frame data frame specific is where that object type is. Some useful methods if your data frame was a little bit larger. I think I have some data in here as well. I do. Yay. Yes. We also have pd.read_csv specifying CSV file. So in the curriculum, hopefully if you haven't made a notebook like I did in this particular folder, in the data folder, I have a few CSVs just for you to mess with, just in case your internet wasn't working and you had to download them. But you can read in CSVs just like this, specify the path, reading it in. Let me go df. Scoot this over a little bit. Sorry, I'm going to close this guy so you guys can see him. So that's just me reading a data frame. This happens to be a diffusion data frame. You can know about it a little bit later. But some helpful functions, especially because you can see how many rows is just like before. There's a bunch of helpful methods. You've got head, prints like the top 6, top 4, top 5 rows. You can specify more if you want. Top 10. Quick rule view. That's a really nice one for the preview. We also have df info. Basically, it'll sort of do a quick look across all of your columns. You'll see the column names here, how many of them there are, the numbers of them that are not null or NAs. It will do a quick little info spec for you, and also the D type. Other good ones to know, df.describe. Also do a really quick, more than 5 numbers, about 8 number summary for you on the numeric columns. And if you have strings, it'll sort of skip them. Or I think there's numeric only capacity option. And so you can see if you have your data frame and you wanted to do a quick mean, standard deviation, min, quantiles. Again, people are coming from tidyverse, this is summarize.
How did it know what your working directory is?
My working directory is based on the fact, thank you for the question, that I made my notebook right here. So my untitled Python notebook is right here, so I'm starting from right here. That's sort of implied. If you don't know and you need to check, I'm going to insert a cell. You can actually technically type bash in Python notebooks. If you start with an exclamation point and you do pwd for working directory, it'll also print out where you are right now. The exclamation point tells the cell that you are now in bash. So you have to type bash.
Got it. Thank you.
Oh. So technically, yes, you can also do pip install from here. I just think it's wonderful. It'll give you a bunch of outputs, so I don't tend to do it. But to each their own. Okay, so data frame. How do we want to index it? Let me close this file browser so we have more space here. Again, we can refer to it by our row. Want to do otherwise indexing? We have iload for index location. We can do just our like before 1, 2, 10. 1 through 10. Notice that we have dropped that 0. I'm literally explicitly saying 1 through 10. And also note that it's exclusive. That's it says Python thing. Our ending number tends to be exclusive. Not always. You do have to read the docs for which one's inclusive, exclusive. I can't keep track of it either. I just sort of do a setting check myself. The other nice thing is that we can also specify it by what's known as an index. So data frame, I do set index, subject ID. I want you guys to take a look at the output right now. Everything seems to be the same font color, right? Except for your column headers and your index and your row index. If I set column to be subject index, notice what changed. Right? The subject ID dropped down. It's also now in bold. So that's your new indexing by row. In order to set an index, you do need to have it be unique-ish or unique enough. You sort of see subject ID is not that unique, but you can sort of try to do subj one. Subj.iload, sorry, load is for name. So I'm going to do subject underscore 000, as opposed to doing it by their positions. If I do that, notice that all of my sub-indexed ones are for subject 000. So you can do it by strings as well. But it depends on if you have that set as an effect. The print does indeed help you. You can always, of course, query. Index. If you do .index, it'll tell you what index are available for you to subset. So again, all of these properties, all of these methods, their attributes are only available to you because this is a data frame. And this data frame with these set properties and attributes that you can mess with. Okay, so that's how you do that. If I wanted to go down, just to give me some space, if I wanted to get only a specific column, no need for any sort of load. You can just subset into it based on columns. So let's do RD and FA. Do it that way. Again, just like Python, you can keep on chaining anything you can actually do the mean now. Doesn't buy column, it's sensible. Okay, any questions? Great. One of the most powerful utilities for data frames is because of the fact that you have, so I can see it. We have, of course, string identifiers for subjects. Here, I mentioned this is the Fusion data set. It also has our tracks, like tracks. Nodes, basically, how many times we sample along that track. RD, FA, CL, ED, MD, all of these are familiar with lingo, some measure of diffusivity. Fractional isotropy, radial diffusivity, diffusivity, may have heard these words sprinkled around before. They're just measurements of water. So if I wanted to very specifically get the average FA by subject, only for the left thalamic radiation. I know it's a lot of words, but we have a bunch of different tracks in here. So let's actually first filter so that we only have one kind of track. Just like our conditionals before, we can do df track ID equals fabulous. I want to show you what happens first. So when we set up this conditional, I run this, you sort of see a really long trues and falses. That's where track ID equals left Latin abbreviation. How do I subset it? Wrap it around another brace. And that way now we only have the left Latin abbreviation tracked. Scroll down to the bottom of this printout. It's just left Latin abbreviation. Okay, cool. Now, yes. Yes. This is actually my working process. I don't tend to save out a very one done. And also this is why I go cell by cell, is so I can keep on pressing run on this one cell until I'm happy and set what I want. You, of course, can do it iteratively. This is up to you, personal preference. Sort of exposing my thinking process on this. Now we can then do group by dot by subject ID. Okay, take a look. Prints. Now there's not a very informative print. That's because we've made it into a data frame by object. Holding my belief by subset onto another column. Notice the chaining. Notice how long this chaining is done. I want to specifically operate on the FA column. So, okay, series group by, something's changed, something's worked out. I just want to calculate the mean. Yeah. If you wanted, this is what is known as a pandas series. Basically, it's just one column. I want to put it back into a data frame format and do reset index. So this is actually 1, 2, 3, 4, 5 commands long. If we were to do it in a normal wraparound function kind of way, maybe 4 for the filtering, but wraparound function kind of way. But this is sort of the power of Python in terms of its left to right readability. If you wanted to chain it up this way. If you want to also maybe not have it span across the entire screen, you can wrap this whole thing in a parentheses. I'm just going to put a space right there so you can read it a little bit better. So basically what I did was only for the left emblemmatic radiation, I wanted for every single subject their average FA. Okay. Left GFFA maybe, sign that to be a variable. Okay, cool. GFFA to CSV FA 50,000. And then if I open up my browser, I can refresh. There she is. If you don't like your row numbers, I will also, and I have to index equals false. I check over on my data frame, close it, refresh. The row numbers go away. Okay, up for you to have them if you want. You don't have them when you use it. Any questions so far? Good. Oops. Last thing that is quite nice about Pandas data frame is that I mentioned the set index one before. See if I can, maybe I want to read subjects. So let's do that. df equals p dot score data subjects. That's the speed. Quick check. Subjects spell. Close that again, just so we have more space to read this. So this is another data frame also in there. I believe if I remember correctly, this is for demographics. We can also do things like add additional columns. So if I wanted to add additional columns for, let's say, if I remember this particular sentence, they did an analysis for males and females separated by if their age is under 10 or not. So age under 10, I want to do column called age under 10 for this particular data frame. We can do our element-wise math or Boolean operations, just as we normally would. Age 10. Find the top.
Ages.
Thank you, because I can't spell. So you can see very quickly we can add columns. That's very specifiable. But here's the thing that I wanted to really show you that's pretty powerful about this is that instead you can index off of, let's say, a subject. You can actually do what is known as a multi-index. GF set index of list. a subject ID and also, let's say, age under 10.
I think the ages are not on the.
I believe there are some in the back. Let me check with. Can't remember. My brain's like. Less than that. There are people in the. But you can now specify specifically a particular subject ID. So. Remember how before we were using the index look for just subject, we can now do for two things, so subject 000, comma, false, is a boolean, false. Gotta enjoy that. Watch me try to debug that. I think it's because I did it already. This is by building blocks, but also not all. There you go. Sorry, I overrid it with df, setting it equal to df twice. You can't do it twice in a row. So now you can actually index by multiple things rather than just one. So it looks like there's only one subject is false. That does make sense because that subject happens to not have less. But you can imagine doing it for that or any other category, male, gender, whatever else you have it. You can have multiple indexes and you can specify it more than just once. You can also do group bys on more than just one as well. So you can do even more. So yes, go ahead.
What is this little thing you do that makes it summarize?
It's a summary, describe.
Oh,
Describe.
no, like you were seeing the table and then you did something that made like a little summary thing.
I'm gonna scroll up. So you tell me when to stop. I'm not super sure.
I mean, you rewrote it, like you know, so I don't think we can see it. So, you know what I mean? Like,
Like getting a
can you do Control Z?
I can control Z all you want. Yes.
Okay, so let's like print right now. Alright, so we see this, and then how did you make it just being like a tiny little thing?
I mean like this.
No, not Control Y.
Why?
Like one step forward.
Control shift.
Maybe because you just deleted print. If you delete print, what happens?
More like if you wanted to make this print out smaller. Is that the question?
Yeah, like you know, so you know what? I just watched the video. You just did it super fast, I think.
No, I'm sorry. I can also.
But also, I'm not very good at explaining what is it.
Anyone else can help me find.
You know,
What I
like this table, and then you did something real quick, and it became this like little summary of how many of this, how many of that.
Yeah. Oh, before the error and then to this point, or before the.
No.
You may need to watch the video back.
Yeah.
Sorry. Try to usually dictate what I say in my thoughts and I do them fast. I'm always. Comment sounds.
It is.
Oh, this.
The print is okay.
Okay, so I commented this out because this was printing out the data frame. Yeah. I noticed that if I print a data frame, it doesn't print out nicely. And so if you let it sort of render on its own, just to work with the system, this is how it's done. So I comment this out. So the last thing to print will be this last line. And so this was actually the subsetting on subject 0, age is less than 10 is false. And like I was mentioning, so that's something that. This one? Yes. Comment this, go back to here. So notice how the index columns, there's 2 bold columns now. And also the fact that these 2 are lower down than the actual columns themselves. That means we can actually refer to or find rows based on this index. So if I wanted this first row, instead of having to say row 0, I could say I want subject zeros, age is false. I could have made it gender, or I could have made it subset. Basically, if you have other indexable kind of columns, this is a really nice way to do it. It's also something that happens naturally. I'm going to go back to the original here. Rereading the data, so it comes back to the original. When we do group bys, copy, paste, and I want to do two columns of group by. Let's do gender and then age under 10. And again, I want to do the average FA. Column F1 not found. I'm 2D5. There is no
Yeah, 'cause
FA.
we're in this-
Let's do IQ. That was the other one. Thank you. Let's just do IQ. Oops. Let's make it a data frame as well as we said. You notice over here, now we're grouping them up by gender, false, sorry, female, false, female, true, male, false, male, true, because those are all options. So you can see sort of the power of the group by, and then your average sum of statistics. Oftentimes, this is how I get my numbers I report in my papers as well. Very quick demographics, things like that. All right, cool. I believe we have very little time until the end of our session. Check that. Schedule is until noon. Yeah. So we have very little time for visualizations. That's because this used to be a completely separate session. So here we are. It happens to have the whole visualizations are not too different across coding languages. I just want to say one funny thing about Python is that again, people come from MATLAB. Guess what the package means? It's called MATLAB. Once again, someone got too fed up that MATLAB could do the plotting and Python couldn't. And so they basically rewrote every single MATLAB function here. The specific one is that if you notice matplotlib is the main function. They have a lot of actual different things at that level. .pyplot is a specific to the plotting. So if we're going into the package matplotlib, there's a module called pyplot. There's other modules like colors, legends. You can sort of imagine what those are for, then based on the name. But specifically, the plotting function is typically pyplot, and people also typically shorthand it. That's because plot is actually a base function. So they don't want to overwrite that. Again, if you're familiar with MATLAB plotting, figure, axis, here's your figure. Here's some numbers. You can plot a line. You can plot multiple lines. Plotting in Python is very similar to plotting in MATLAB. Basically, it's layer based. First line, second line, third line. You basically add it on top. Every single thing you add. You can mess with the colors. You can mess with the. Sorry that I'm going to spread. But if you have any specific questions, feel free to reach out to me and ask. Right. You can add as many as you want. So if we want to plot the first trial, second trial, third trial, different color names that are available to you. You can add a label too, so that when you plot the legend, it automatically matches that aesthetic for you up here. You can mess around with every single thing you see on the figure, just like in other languages, adjust it. So this is just very basic plotting. You can add on top of that different line types, different line types, different markers, stuff like that. Change the figure titles. Anything you can do with other plotting software, you can find that. Matplotlib is your base plotting function. Sorry, package. I did want to mention something very quickly as I scroll through. Welcome to the track class. Multi-plot, figure the axes. You got other plotting languages to do this too.
Can you like save these as like
Yes, we can. Let me just really quickly check for you. So if you do import max plots, plots, big axis plot subplots that was in that we saw. Let's open up just subplots. There you go. Here's just an empty figure. Big dot save. figure.png. Save as. Darn it, save. There's so many images. Save thing. Save thing. There it is. PNG. I believe the next argument is DPI, so if you wanted to go up in a resolution for article ready figure. It's always save as, save. You can see my map on this too. Recognize these terms. Okay. So move back out so we see a little more. As many figure plots as you want, this whole thing can be saved out. That seems all sensible. Scatter plots, usual stuff. The one other plotting package I did want to mention before I set you all free for lunch is there's a package called Seaborn. This is again a Pythonic solution to ggplot in R. So if you guys know anything about that, that is where this comes from. Seaborn, this is the SNS, shorthand for it, is instead of specifying here's my X value, here's my Y value, color, whatever. Instead, they take a data frame usually. Notice the specification, data subjects. This is a data frame subjects that we saw before. X, what's going to be plotted along the X-axis? And what's going to be plotted along the Y? IQ. Change the color based on that gender column. Palette, dark and dark gray. That sort of specifies a spark plot. Okay, again, this is a more holistic version of specifying a plot. So what happens is that you have to prepare your CSV or your data frame beforehand before you submit it to Seaborn. And then it'll sort of try its best to figure out what kind of data you have, plot it accordingly. In this case, handedness is a categorical. So we got a left and a right hand, left hand. IQ, it made sense of things and decided to plot the mean IQ within each group and colored based on the gender. So we have another categorical split box there. So there's a very quick way to get a bar plot just from a data frame. And so pandas and Seaborn play really nicely. That's sort of the intent.
How, where do we define the error bars?
The error bars are another argument. By default, I believe these are 95% complex. Or you can specify standard error mean. I will really quickly import Seaborn here. Import, I hope I have it. Seaborn as SNS. Seaborn bar plot. Do a question mark. It'll print for you a bunch of the arguments that you didn't see specified automatically. This should also be available to you on the Seaborn's documentation site as well. And you can sort of see error bar, CI 95, scroll down some more. Here's our docs for specifying this. Oh, cool. String, expects a string or a number, a tuple or a none. It'd be either CI, PI, SE, SD, as our usual error bar metrics can be. And so Seaborn tries its best based on the data you give it to make a sensible plot. There's more than just bar plots, of course. Got swarm plots, bloom plots, histogram plots, 2D distributions, yada yada yada, heat maps, all the things. They're all available to you. Spots, of course. If it fit lines for you, once again, if anyone's familiar with ggplot, you can do it's smooth, excellent. Of course, we also have our image types as well.
Sort of like DICOM, maybe.
Yeah, so there's another package to read DICOMs and stuff, but once it gets in, it's a matrix in NumPy most of the times. Even more funny, once again, the MATLAB is showing that. IM show is in here somewhere, match show. So very similar mapping one-to-one. Python in terms of making this. If you are ever at a loss for how to plot things, Seaborn, next one. Image gallery, I think it's the first one you saw there. Welcome to the land of infinite plotting. You want inspiration for any of your plots that Seaborn can do and people have made. Here you are. The keyword usually is gallery of some sort, and people will show off their coolest visualizations, usually through the documentations. So heat maps that I didn't manage to show you guys, cool connectomes with like extra clustering stuff up here, like again, and then they provide code. So take it, please use it. Don't reinvent the wheel. Heat maps, this was like a 2D histogram. Basically, plotting should be pretty easy too through AI. I've actually had a lot of success being like, I want a histogram that overlays many colors from different categories on top of each other. Usually AI is pretty good with that, so give that a go. You wanna give some fancy distributions. But for the most part, these are built off of just two packages, at least within Python. You may also encounter interactive graphs. Don't really cover that in here, but plotly is a nightmare, but it is very nice to do graphs that will do things like this. Cool stuff like this. Where's that? Well, darn. Well, so basically, if you ever seen something rotate, or if you want to change, try to actually not find it, so I'm just saying. Interactive plots. Example. Where you can zoom in, you can. There we go. Like things like this, if you want to make them interactive. This is a pretty dumb graph to make interactive, but you can sort of imagine much cooler ones. I'm just like, why am I showing a bar chart, line chart, moving up and down? Here. On stuff like this. Maps are probably better to show. Yeah, there you go. This is better. With hoverovers and things like that, different colors, you click on them, they do different things. Plotly is also something you'll encounter in terms of interactive graphs. These also will run in your notebook, and then this particular cell will have this as an output. So you can mess around with it as you see fit in the notebook itself. And then yes, you can save these out as HTMLs, send them off, and have them be interactive cells. So here's some useful resources for you. Okay, maps are better examples, but these are your pretty big ones. But at the base level, most of this stuff comes from some sort of CSV, some sort of numerical matrix that they represent into plotting form. Okay, sorry for the speedy at the end. This was a lot of stuff. It's lunch. All right, that was it.
Thank
Thank
you. What
you.
a wonderful one.
Yeah. Oh, there's a lot of info.